Hello guys, welcome to our YouTube channel Tronicia in the course Number Systems. In today's lecture we will see how to convert a binary number into hexadecimal number, and it is a part 2. What we saw in the part 1 was the conversion of the natural numbers, and in this part we will see how to convert the numbers with a fraction. It is very simple. What we have to do first, we have to see the left hand side part, that is the real part, and the first step is that we have to divide the number in the groups of 4. So this is a first group and this is a second group, and now we have to write down these groups individually. So we have to write as 0 1 0 1, and this group here, that is 1 0 1 1. Now we have to convert this into its what we have to convert this into its decimal form. So 0101, on converting we get 1 into 2 raised to 0, which is equal to 1, plus this term gets cancelled because 0 into anything is 0, plus 1 into 2 raised to 2, which is equal to 4, and also this terms gets cancelled because 0 into anything is 0, and hence here we get the decimal number as 5. Now converting this into its decimal form, we get 1 into 2 raised to 0, which is equal to 1, plus 1 into 2 raised to 1, which is equal to 2. Now 0 into 2 raised to 2 is equal to 0, and 1 into 2 raised to 3 is equal to 8, and hence 8 plus 2 plus 1 gives us 11. Now we can see here that during representing a hexadecimal number, we can't write the number as 10, 11, 12, 13 like that. We have some letters which represent the value of 10 to 15. So our number 11 is represented in hexadecimal as B. So 11 is replaced by B, and this 5 B5. So the real part, the conversion of a real part of the binary in hexadecimal is B5. Now we will see what to do about the fraction part, that is about the right hand side from the binary point. We have to do the same thing. First we have to write down this number as a group of 4, 1 1 0 0. From left to right side we have to start grouping of 4 4. Now we get a 1 1 0 0, and we have to do the same conversion. What we have to do, again convert this into a decimal number. So 0 into 2 raised to 0 will be equal to 0, plus 0 into 2 raised to 1 will be equal to 0, plus 1 into 2 raised to 2, which is equal to 4, plus 1 into 2 raised to 3 is equal to 8, and so 8 plus 4 is 12. And again the same thing, we cannot write it as the whole number 12, but instead we have to represent this 12 as the letter, and here we can see in the reference that the number 12 is represented as the letter C. So we have to replace it by C, and hence we have to write down this C in the continuation of this number, and hence we get our final hexadecimal number as B5.C with the subscript 16, as it is a hexadecimal number. So it was very simple. So again, now we are going to the second example. The same thing we have to do. First we have to make the group of 4 4 4, and write down the number 0 1 1 0, and same for here, we get 0 0 1 0. Now write down these four numbers. We get 0 1 0 1, and for this 1 1 0 0, which is, I'm sorry, 0 1 1 0 0, which is this final group. Now we have to convert these all groups into its decimal form. Hence 0 into 2 raised to 0 will be equal to 0, 1 into 2 raised to 1 will be equal to 2, plus 1 into 2 raised to 2, which is equal to 4, and 0 into 2 raised to 3 will cancel out, and so 4 plus 2 will be equal to 6. Now converting this into its decimal form, 0 into 2 raised to 0 gets cancelled, then 0 into 2 raised to 2 also get cancelled, and 0 into 2 raised to 3 also get cancelled. So we have 1 into 2 raised to 2, 1 into 2 raised to 1, which is equal to 2. So our second digit is 2. Now we have our decimal point here, and now 0 1 0 1. Now 1 into 2 raised to 0 will be equal to 1, plus 0 into 2 raised to 1 is 0, then 1 into 2 raised to 2, which is equal to 1 into 4, that is 4, plus 0 into 2 raised to 3 is 0, and so it becomes 5. Now 1 1 0 0. Again the last two terms get cancelled as 0 multiplied by anything is 0. Then 1 into 2 raised to 2 is equal to 4, plus 1 into 2 raised to 3 will be equal to 8. And now 8 plus 4 is equal to 12. And now the same thing, we cannot write it as 12, so we have here C, which is the value of 12 in hexadecimal conversion, so in hexadecimal number system. So instead of writing 12, we have to replace it by C. And now joining this, we get our final number as 62.5C, and this is a hexadecimal value, and the subscript is 16. Now let's take another example. Yeah, 0 0 1 0 0 1 0 0 dot dot dot. Now again we have to do the same. We have to divide it in group of 4. This is a first group, this is a second group, and here and the and this is a third group, but it is not but we don't have to write the third group, because on the left we can add n number of zeros, but it doesn't matter for the number, so we can cancel out this 0. Now we have here two groups, 1 0 0 0 1 1 1 1. Now on the right hand side we have a group 0 1 1 1 1, and again as I said, we can write any number, n number of zeros on the right hand side, but eventually our number won't be changed. So again we can cancel out this 0. We can cancel out this 0. Now what we have to do, we have to write down the groups. First group is 1 0 0 0, second is 1 1 1 1, then a decimal point, and on the right hand side we have 0 1 1 1. Now converting these groups into its decimal value, we get 0 multiplied by anything is 0, so these three terms will get cancelled, and 1 into 2 raised to 3 will be equal to 8, so hence 8. And for this, 1 into 2 raised to 0 is 1, plus 1 into 2 raised to 1 is 2, plus 1 into 2 raised to 2 is equal to 4, plus 1 into 2 raised to 3 will be equal to 8. And so we get 8 plus 4 plus 2 plus 1, which is equal to 15. And on the right hand side, again the same thing, 1 into 2 raised to 0 is equal to 1, plus 1 into 2 raised to 1, which is equal to 2, and 1 plus 1 into 2 raised to 2, which is equal to 4. And again 0 into 2 raised to 3 is equal to 0. So 4 plus 2 plus 1 gives us 7. Hence our number is 8. The first term of our hexadecimal number will be 8. And we all know that we cannot write the number as 15. So we have to write down the letter, which is F, because 15 is replaced by F in hexadecimal. So 8F.7. So this is our final value we got after converting, with the subscript 16 as it is in hexadecimal. Now let's see another example, the last example, 1001111.01. Okay, this is one, this one is not visible, yeah, .01. Again we have to do the same thing, we have to divide it in groups of 4. This is a first group of 4. Now we can see here that only 0 and 1 are remaining. So what we have to do, we have to make it a group of 4, we have to add 2 zeros on the left hand side. So this is a second group of 0 0 1 0, and similarly we have to add 2 zeros on the right hand side of the decimal point to make it a complete group of 4. So 0 1 0 0 makes it a group of 4. Now again we have to write down these groups individually, that is 0 0 1 0. The second group is 0 1 1 1 point, and on the right hand side we have a group 0 1 0 0. Now converting this into its decimal form, this 3 digits, that is 0 into 2 raised to 0 gets cancelled, then this 0 into 2 raised to 2 gets cancelled, and 0 into 2 raised to 3 also gets cancelled. So we are left with 1 into 2 raised to 1, which is equal to 2, and converting this group into its decimal form, we get 1 into 2 raised to 1, which is equal to 2. No, I'm sorry, 1 into 2 raised to 0, which is equal to 1, plus 1 into 2 raised to 1, which is 2, plus 1 into 2 raised to 2, which is equal to 4. So 4 plus 2 plus 1 is equal to 7. And same for the right hand side, 0 into 2 raised to 0 is 0, 0 into 2 raised to 1 is 0, and we are left with 1 into 2 raised to 2, which is equal to 4. Now we can see here that we don't have to use the letters, as no digit is exceeding the value of 10. So joining all these numbers, we get our final value as 27.4 in hexadecimal number system. So this was a quick tutorial on how to convert the binary numbers along with the fraction part into its hexadecimal equivalent. If you have any doubt and queries, you can ask it in the comment section. Also, like this video and subscribe to this channel and share it as much as you can. Thank you.